This is one of a series of revision sessions produced by the Further Mathematics Support Programme. In particular, in this one we're looking at Edexcel FP1 unit and the topic coordinate systems. And coordinate systems for FP1, then you're looking at two of the conic sections, The two in particular, the parabola and rectangular hyperbola. You're expected to know the standard equations for those. Y squared equals 4ax, and for the hyperbola, xy equals c squared. Often, of course, you will have written this as y equals c squared over x. The standard equations give a parabola, which is its axis at the origin, and then the line of symmetry being the x-axis. And the hyperbola is a rectangular hyperbola with its two branches in the first and the third quadrant of the graph. The only thing that you're required in terms of parametric equation is to realize that we can represent points on these curves by parameters, so we can have a particular value given by for the parabola at squared and 2at, and for the hyperbola at a point ct and c over t. So for particular values of t, the points move on these curves. You are also expected to know what's called the focus directrix property, so that the parabola, as I've already mentioned, is one which is centered on the x-axis with its apex at the origin. The focus at a point here has coordinates for the standard parabola, has coordinate s, sorry, I beg your pardon, we normally call it s, it has coordinates a, 0, and the directrix is a line at x equal to negative a. You are also expected to realize that what's called the focus directrix distance property is such that for any point on the parabola, the distance from S to P is equal to the distance from P to the directrix, so that this idea, the equidistant property, is that PS is equal to PX. This will tie in with later modules for FP2, where you look at more of the conic sections in a little bit more detail. You are given these facts actually in your table, so do be aware of that. You don't need to learn these things, they're actually stated for you. So we're looking at the page from the module at the moment. Sorry, from your statistical tables, I beg your pardon. The other thing you need to be able to do for both of these curves is to find tangents and normals. Now, this is no different for finding tangents and normals from work you've done in your core units, so C1, C2, for example, so that the method is entirely the same. You find the gradient of the curve at the particular point that you want the tangent and the normal, and then use that in the standard formula for a straight line. Y minus y1 is equal to gradient times x minus x1. Remembering that for the tangent, m is equal to f dashed at the point, it's the derivative at the particular point that you're talking about, so f dashed of x1, and for the normal, m is going to be -1 over that at that particular point. So that's standard method for finding tangents and normals. The specification is clear that you do not need to use parametric differentiation, neither do you need to use implicit differentiation. So parametric differentiation refers to that idea that we can use parametric equations, and the implicit differentiation is one where we can look at the equation in particular of the hyperbola as being xy is equal to c squared and differentiate that. So I'm not going to use parametric or implicit differentiation in the questions that I'm going to be doing, because those aren't required. However, that's not to say that if you've been taught those that you cannot use them. You can. In fact, any method of finding the gradients is okay for this particular part of the course. Right, moving on to some questions in particular then. This is from the January 2010, as it says, and we're looking in this particular case at a parabola. So the parabola is y squared equals 12x, and the first part is simply asking us to write down the coordinates of S. So the write down is nothing particularly fancy. This you do need to realize, of course, that y squared is 12x can be written as y squared is equal to 4 multiplied by 3 times x. In other words, I'm writing it in the form y squared equals 4ax. In other words, a is equal to 3, and therefore the coordinates of S, just from knowledge or looking up on your tables, your statistical tables, is that the coordinates of S are 3, 0. It's a B mark there for that. There's no working as such which is going to gain you any credit, so you either get the mark or not. The second part of the question uses that idea and just asks us, uses that point, I beg your pardon, and then asks us about the perimeter of a trapezium here, which is marked on the diagram. Now what we're going to be using is the idea of focus directrix distances and also knowledge of the directrix, because we're told that points A and B lie on the directrix. So you can see that this question is then just checking on your knowledge of the parabola. Okay, so I'm going to do that on a new page. We are on the new page. I'm going to write in on my diagram some coordinates now. Quite a good idea for you to do this. We know that S is at 3, 0. We know that the directrix X is therefore -3. And the question had told us before that P has X coordinate equal to 1/3. So we need to work out, I think, first of all, the y coordinate then of B. So looking at that, well, we can get that simply by using the equation, so that if y squared, sorry, I just changed the color of that pen. Now, if y squared is equal to 12x, then y squared is equal to 4 when x is equal to 1/3, and therefore y is equal to plus or minus 2, but we're told that P is positive, so then that coordinate of P must be at 2. Well, that now gives us enough information to work out the perimeter of ABPS. Clearly, S is distance 3 from the origin. A is also distance 3 from the origin. We've just calculated AB is equal to 2, the Y value. BP is 3 plus 1/3, so it's 3 1/3. So the only thing we're left with is PS. But PS, we can state that PS is equal to PB. This is the focus directrix property saying that the point is always equidistant from those. And therefore, these are both equal to 3 1/3. So that the perimeter of the trapezium ABPS is equal to, it's AS is 6, AB is 2, and then the other two sides are both 3 1/3. If you add all of that up, it comes to 14 2/3 units. The marking for that part of the question, there are 5 marks. So the marking is as follows. There's a B mark for getting this x equal to -3 with that knowledge of the directrix. There was an M mark for knowledge of the focus directrix, distance there. A B mark for using the equation to work out y. A method mark simply for adding up all of these numbers, and an accuracy mark for getting the correct answer at the end. The second question deals with rectangular hyperbola this time, so we've got xy equals c squared, and we're told this time that we've got a point with coordinate 3c. So the first part of the question again is just to write down the value of y. Well, this is just a case of substituting the value 3c into the given equation, so that we get that 3c multiplied by y is equal to c squared, and therefore the y coordinate of A is equal to c over 3. A simple B1 mark for that. Again, no method marks at all. You either get that mark or you don't. It goes on now to use this idea of finding either the tangent or the normal. In this particular case, we're asked for the normal, and we're given the equation of the normal, so we need to show that this is in fact the normal at the point A. So we've now got the point 3c and c over 3. The question goes on, once we've proved that, to find where that normal meets the hyperbola again. So just looking at that, if you can't do part B of the question, they've been quite kind here and given you the actual equation of the normal. So if you can't get that, then it is still possible to go on and do part C of the question. Right, taking those one at a time then, the first thing we need to do is to show that the equation of the normal to h is in fact 3y equal to 27x minus 80c. Very specific about the way they want us to write it. Well, we need to start off by using calculus to work out dy by dx. So I'm going to do this by writing y is equal to c squared over x, and therefore differentiating that, dy by dx is equal to negative c squared over x squared. So that at A, where we know that the value of x is 3c, dy by dx is therefore equal to negative c squared over 3c all squared. So it's negative 1 over 9. That of course would be the gradient of the tangent, but we're asked to find the normal. So that means that the gradient of the normal is equal to negative 1 over that, which is equal to 9. And therefore the equation of the normal is given by our standard equation, which is y minus y1, and y1 we'd calculated to be c over 3, that was the y value, is equal to 9 multiplied by x minus 3c, so x minus x1. Multiplying by 3, y minus c, and also multiplying it out this bracket, so 3 times 9, 27 x, and then 3 times 9 multiplied by 3, 27 times 3 is 81, so minus 81c. Well, we've been asked to write it with 3y as subject, so therefore 3y is equal to 27x minus 80c. Okay, the marking for that would be as follows. There's a method mark and an accuracy mark in the differentiation. So the method mark for actually attempting the differentiation and at least getting the change of power from x is negative 1 to x is negative 2. So that's the method mark, and then an accuracy mark for getting that correct expression for the algebraic differentiation. Going on from there, there's a method mark and accuracy mark for getting the gradient of the normal. And then finally a accuracy mark for the equation, sorry, the working up to that equation. Obviously you're given the equation and therefore it's not for that. It's just for having no errors in your proof, because we've got it's a show question, so any errors are going to lose that final accuracy mark. The other way you could have worked out the equation of the normal, of course, is to use y equals mx plus c. So I'll just make a note of that, that methods which use y equals mx, I'll write it as k because we've already got c in our question. Y equals mx plus k, and calculating k correctly would be equally as good a method for getting all of that. Okay, the next part of the question goes on from there and says that the normal then meets B at some other point, and we have to find the coordinates of B. Now there's no need to draw a diagram, but just to illustrate what's happening here, the rectangular hyperbola is of this form here. we've taken a point somewhere, doesn't matter in fact where, and found the normal to that. So we've got the equation of this normal, and whoops, should have been a straight line there, and so we're looking for this point down here on the other branch of the hyperbola. Worth having an idea of a sketch in your mind, or even drawing one, so that you can check that things are going okay. Well, this is a standard method now of solving two equations, isn't it? We know that our normal is 3y is 27x minus 80c, and we know that the hyperbola is xy is equal to c squared. So we simply need to solve these simultaneously. Well, there are different methods of doing that, but one way is from this first equation to show the second equation rather here shows that y is equal to c squared over x. So we can then substitute that into the equation of the normal, so that 3 times c squared over x is equal to 27x minus 80c, multiplying by x and rearranging it as a quadratic, 27x squared, so multiplying here by x to give 27x squared. The x term comes from the minus 80c, so minus 80c times x, and then finally minus 3c squared is equal to 0. Now we've got to find the roots of this, in other words the points where it's equal to 0. Now you may find that the factorization there is a little bit tricky maybe. However, remember that we do know that the x coordinate of this point here is actually equal to 3c. So we can be a little bit clever and use that idea in our factorization, because we know if x is equal to 3c that one of the roots, or one of the brackets here, the factors, must be x minus 3c. And that makes life a little bit easier for us to realize that the other factor must be 27x and plus c. So that the x coordinate of our point B is at negative c over 27. So the x value is equal to negative c over 27. And then the y value is therefore equal to negative 27c. The marking for that, there were method and accuracy marks for the first part where we're using the simultaneous equations. Here M1, A1, the first part. A method mark for the factorization, and then 2 accuracy marks, one for x and one for y. Okay, that completes the lecture on coordinate geometry for FP1 at Edexcel. There are other sessions available for the other units or the other subjects in FP1, and also for all of the other units for Edexcel and other boards.